Rehabilitation of the San Josep building in Vall de Núria, starting from the roof. The Vall de Núria is situated in the heart of the high mountains of the Catalan Pyrenees. In the valley, the source of many springs and streams, is the artificial lake and the sanctuary of the Mare de Déu de Núria. The current church was opened in 1911. The sanctuary is located at an altitude of 1,964 meters above sea level, at the point where three valleys at almost 3,000 meters come together. Due to its geographical situation and climate, it possesses flora and fauna typical of Central European and high alpine mountains, where there are plant and animal species that are endemic to the Pyrenees. The only way to reach the valley is either on foot, along some of the mountain paths that reach Núria, or on the rack train. This has become one of the typical icons of the valley and of the county of El Ripollès, by being, along with the Montserrat rack train, the only ones of their kind in Spain. The sanctuary of Vall de Núria, owned by the bishopric of La Seu d'Urgell, is made up mainly of the church and a series of interconnected buildings, San Josep, San Justí, San Antoni, and San Gil, designed by the architect Josep Danès and built between 1923 and 1955. Ferrocarrils de la Generalitat de Catalunya, the Catalan railway company, are responsible for promoting the conservation and maintenance tasks. In 1982, the Generalitat de Catalunya, the Catalan government, through the Ferrocarrils company, began the rehabilitation and improvement of the heritage of Núria. The first aimed to halt the progressive degradation of the complex and its infrastructures. These turned up serious structural deficiencies that had been concealed and major shortcomings in installations, services, and infrastructures. The San Josep building, the longest wing of the series of buildings of Vall de Núria, was almost totally closed off to the public, jeopardized by the lack of safety. The project and direction of the work was commissioned by Ferrocarrils to architects Adario and Morato. The rehabilitation of the San Josep building, as well as the enlargement of the hotel complex, was awarded to the temporary consortium consisting of Natursystem and ESTRUCAD METÀL.LICS. Natursystem, a construction company of the Capisa Group, specialized in the rehabilitation of historic and emblematic buildings, was in charge of the demolition, masonry, concreting, and finishes, has taken part in the work of the Palau de la Música Catalana and the Roman monumental complex in Barcelona, while ESTRUCAD METÀL.LICS, specialized in metallic structures for buildings, civil works, and bridges, was responsible for the calculation, design, manufacture, and assembly of the metallic structure and roofing, and among other projects, has taken part in various buildings of the new Terminal 1 at Barcelona Airport and several stations on Metro Line 9. The rehabilitation work at the Vall de Núria has the following goals: the preservation of the heritage and historical physiognomy of the Vall de Núria, improvement in communication, accessibility, and comfort of the complex, improvement in the facilities and accommodation services, the use of geothermal energy and maximum energy efficiency, for which the San Josep building has obtained the Green Building Prize awarded by the European Union. The San Josep building was a rectangular construction with a ground plan measuring 60 by 11 meters. The ceilings, ground floor, first and second floors, and the attic were formed of wooden beams with Catalan vaulting. The rectory also had a low ceiling basement. The maximum height of the building with regard to the level of the ground floor was 12.3 meters. Given that one of the conditions of the project was the creation of a new basement below the entire surface of the building, and that the facades had to be maintained to conserve the historical physiognomy of the sanctuary, it was necessary to solve some structural and construction problems in the old building, yet enabling maximum flexibility of space, both in the present and the future. Therefore, the roof and the ceilings were knocked down given their state of degradation, and the facade walls that mark the building volume and provide the historical image of the edifice were maintained. Taking into account the meteorological conditions in Núria, it was decided to construct the building with a rolled metal structure. Both the manufacture in the workshop and the assembly on site enabled speed and better quality control. The loading of all the elements required for undertaking the work was done at the Cardenal station. We had to adapt to the size of the platforms, their maximum load capacity, and the gauge and width of the tunnels. This aspect was crucial for the design of the metallic structure in order to find the ideal point for the threaded joints. Due to the type of structure, weight, size of the pieces, and the setting of the Vall de Núria, the structure had to be assembled by means of a mobile crane. The smallest crane on the market would not go through the rack train tunnels. So we looked into ways of disassembling a mobile crane in parts, easy to reassemble until it was transportable. The demolition of the roof and ceiling of the third floor left the crown of the facade's load-bearing wall uncovered. The act of demolishing just the roof and ceiling of the third floor enabled the facade to be connected to the lower ironwork and also made for safer working conditions. For the crowning of the facade wall, a continuous perimeter beam was built in concrete over which a continuous galvanized deck was attached by means of small threaded rods anchored with epoxy resin. This system allowed the loads of the portico wall over the wall to be distributed in a more uniform way, a system to control the height levels of the support for the upper structure during the execution of the work, the creation of a structural crowning of the wall, the roof structure to be connected to the facade wall, weight and adhesion to be given to the upper part of the interwall area. The geometry of the porticos corresponds to the ensemble of the roof porticos and beams of the third floor ceiling. These two levels are joined by small side pillars which are supported by the perimeter molding and two central pillars which during the construction stage of the building act as braces, transmitting the load of the structure to the porticos of the roof. This system enabled us to begin the work starting from the roof. Both stages 2 and 3 involved the demolition of the second and first floor ceiling, alternating between the demolition work and the assembly of the new metallic structure levels. Two central pillars take the load of the first and second floors. The beams made up of double metallic beam that supports the structure of the ceiling of the floors, and the central pillars are joined by means of threaded joints. This double beam is supported by the interior metallic hoops placed in the inner face and attached to the wall of the San Josep building by chemical anchorages. From the ground floor, for functional and visual reasons, the pillars that dropped centrally disappear, to be relocated at the side walls. Propping has been undertaken on this floor given that it is the first we find in descending direction of the structure that has sufficient height for the large rimmed main beams. The portico of the ground floor ceiling, like the others, is made up of two main beams that support each of the two end pillars, 4 in total. This stage consisted in the excavation of a new basement. The building was split into multiple areas, the reason for these splits being that the foundations were limited to the continuation of the wall as far as a lower layer, made up of filling and cobbles and gravel. The building was supported on the bed of the Aina wash, and the risk of excavating by traditional methods was high, which is why we opted for injections of cement at low pressure, this system being chosen due to its suitability for this type of work. With the injections coinciding with each portico, the footings are placed within the facade wall and the metallic structure of the basement ceiling assembled. Finally, the ground is lowered and the perimeter closure of the floor is undertaken with the supporting and the walls of reinforced concrete formed in a single face.